Okay, I'm starting with the summary of last lecture. We were studying recursion and 3 points we have summarized. In recursion, the function calls itself. This is the first point. The second point is the function should have a terminating condition, because if it will not have a terminating condition, so recursion or repetition will be continued and you cannot stop it. And the third point is recursion can only be used to solve the problems, which can be further divided into similar smaller problems. Now, next we are talking about that what mindset or what type of algorithms are generally used while solving the problems of recursions. So I'm giving you a few examples. I'm giving actually 2 examples that will help you to understand the concept of recursion. So I say it a shopping example. For example, we are to shop some product. So we went to market, and there is a market which has shops in one side, and at one side the road is closed, so you cannot pass through the market. You have to return back from the road you have entered inside the market. So we have shops S1, S2, S3 and so on up to S7. So what we have done, this is shopping example 1. I'm calling it scenario 1, where what you have done, you have purchased from shop 1, then shop 2, then shop 3, then shop 4 and so on up to you have purchased from every shop up to shop number 7. Now what you have done, you have purchased and kept your goods, whatever you have purchased there only. You have not picked them up, right? So you have purchased and left your product there only with the shops. So you have purchased from 1, 2, 3, so on up to 7. Now when the road will be over, you have to return back from the same path. So since you have purchased the product from shop number 7 at last, so when you start picking the product, you will pick it from shop number 7 first, means from the last shop, and the last packet that you will pick will be from shop number 1, because it was the shop from where you have purchased the product for the first time. So I have demonstrated this with a graph, a kind of picture here, that when you have shopped from 1, 2, 3, 4, so you are shopping. Now finally your picking is pending. So now when you have started picking, so you have started this from 7 to 1. So shopping is from shop number 1, 2, 3, 4, 5, 6, 7. Then when you started picking, it is from 7, 6, 5, 4, 3, 2, 1. Now this is scenario 1. Now second thing, in the same shopping example, what you have done, you have purchased the product from shop 1 and picked. And similarly, you have purchased from second shop and picked. You have not left any job. So when you have finished your shopping, there's no pending work. So you'll just come out from the market. You'll not pick the products, since you have picked the product while you have shopped. Now this is second example. So you have to keep these examples in your mind when I'll explain the questions to you. The second example is of a gift box example. For example, someone has a birthday, he has received a gift and it's a box, wrapped box. So what he has done, he has opened the first box, and then what he sees, there's one more box. Then he opens that box also, then he finds one more box, and finally he found the product. So first he has opened box 1, box 2, then box 3, found the product. Now what is the process to complete this whole phenomena? Like what are the remaining jobs now? So the concept says the innermost box will be closed first. Like if it was the order 1, B1, B2, B3 to open, then the order to close the box will be B3, B2, B1. Okay, B2, B2 has been written twice, so the inner one was B3, is B3 actually. So here, if I've opened the box B1, B2, B3 and there is a terminating condition, means there is no box to open now, then when you close them, it will be B3, B2, B1. So this is the scenario that we have to keep in mind when we understand the problems of recursion. Now let's have an example in which a simple example that we have done in class 11th. It's a function to find factorial. So we have defined a function def fact n is the argument. So we have to multiply numbers up to n. So we have taken a multiplier f as 1, and I'm running a loop from it will become 0 to n plus 1. So let's have it from 1 to n plus 1. I'll commit changes. So it should have 1 to n plus 1. So it'll run from, if n is 5, so it'll run from 1 to 5. Now f is equal to f into I and return f. So all the numbers from 1 to 5 will be multiplied and the result will be stored with f, and finally we'll return it. I've called this function for 5. I've passed the value 5. It has stored into n, then the multiplication f is returned to k, and finally we'll display it. This is the concept number 1. If I explain this example with dry run, so we have three variables f, n and I. N is 5 and f is 1. I is running from 1 to 5, and if f is multiplied with I, so the values that will be stored in f will be 1 into 1, 1 into 2, 2, 2 into 3, 6, 6 into 4, 24, and the final is 120. That will be returned to the function. Now, this is important, something very important, that is, function always return value to the function which calls it. So here the function has been called with the statement k is equal to fact of 5. Then the value that is returned through the function will be stored in k and will display k, because the value, the function has been called from the second last line. That's why it is returning value to the second last line only. Now if I come down where I've written function always return value to the function which calls it. Now in recursion, function can be called from inside, that will demonstrate recursion, or it can be called outside as well, because to run a function it is necessary to call it from outside. Now I have a question that when function will call itself, to whom value will be returned? Now, and the answer is to the same function who has called it, and that is called stacking. Means answers have been stacked. So same function is calling the function itself, and it is stacking, it is storing the answers as well. I'll make you understand this in this example. Now the same program, factorial program, that we are doing using recursion. Here function name I have written is rfact, because I am demonstrating recursion factorial. And now this is something that you have to understood, very important. We have a function rfact, and I have written if n is equal to 1, return 1, else return n into rfact of n minus 1. Now this is something that you have to understand properly. For example, if I say what is the factorial of 1, so the answer is 1. Now think, if n is 1, if someone is asking you what is the factorial of 1, so you will directly say it is 1. You are not to multiply it by any number, but if someone says what is the factorial of 5, then you have to start multiplication. Here it is a terminating condition, that is saying if n is equal to 1, nothing is to be done, the factorial of 1 is actually 1. Now if it is not, for example, someone has passed 3 as an argument. Now how can we execute it? So the initial value of n is 3. Since n is not equal to 3, we have given n as 3. Now this is not equal to 1, so will not return. We'll come to else part. Now return what? Return n, that is 3, into, again call this recursive method for 2. This value will not be returned to the calling program. This is being stacked. It is being collected. So 3 into factorial of 2. Again the next value of n is 2. And since this is again false, so it will say 2 into recursion with 1. So when 1 will be passed, then it will return 1. Earlier, how many multiplications are pending? 1 has to be multiplied, 2 has to be multiplied, and 3 has to be multiplied. That will be 6. That is the answer of this recursion. Now let's understand this using dry run. rfact has been called with 5, this external calling. Now what has happened? Externally it has been called with 5. Now when it has been called with 5, since it is not 1, so 5 into rfact of 4. If it was 1, it should have returned 1. Since it is not, so 5 into rfact of n minus 1. So when n is 5, rfact will be called with 4. Now the first statement that will execute is r into rfact, 5 into rfact into of 4. Next time when it will be called with 4, so n is 4 now, 4 into fact 3, because n minus 1 is 3. When it is called with 3, 3 into fact 2. When it is called with 2, 2 into fact 1. When it will be called with 1, it will return 1. So here in place of 1, it will be 1 into 2, that will be returned. You can see on the left hand side. Then 2 has been returned to fact 2, and now it will be multiplied with 3, so it has become 6. Now 6 will be 6 is the value of factorial 3, that will be multiplied with 4, that will be 24, and it will be multiplied by 5, so it will be 120, that will be returned to the function. So this is the method by which we apply recursion. Now this is a homework for you. You are to display sum of n natural numbers. The hint is factorial is product of n natural numbers, whereas sum is basically sum of n natural numbers. Thank you. Give your feedback.